Have you ever wondered how we measure the amount of ozone in our atmosphere? It's a fascinating process that's crucial for life on our beautiful planet. The ozone layer, a fragile shield of gas, protects the Earth by absorbing most of the sun's harmful ultraviolet radiation. Without it, our world would be a very different place. This protective shield is not static, though. It fluctuates, changes, and evolves under the influence of various factors, both natural and human-made. Monitoring these changes is vital as they can have significant implications for the environment and our health. But how do we keep track of this invisible, ever-changing shield? How can we measure something we can't see or touch? The answer lies in a special unit of measurement, unique to this task. To accurately measure the ozone, scientists use a unit called the Dobson Unit. But what exactly is a Dobson Unit? A Dobson Unit, often abbreviated as DU, is a unique measurement used specifically for ozone. Now you might wonder, why do we need a specific unit for measuring ozone? Well, the answer is quite simple. Ozone is not evenly distributed in our atmosphere. Instead, it's concentrated in a layer, aptly named the ozone layer, which extends approximately 10 to 50 kilometers above Earth's surface. To accurately measure the total amount of ozone in the Earth's atmosphere above a specific point, scientists devised the Dobson Unit. Picture this. If you took all the ozone in a column of air stretching from the ground to space and compressed it to standard temperature and pressure conditions, the thickness of that layer is what a Dobson Unit quantifies. One Dobson Unit corresponds to a layer of ozone that would be 0.01 millimeters thick under those conditions. To give you a sense of scale, 100 Dobson Units, a typical value, would form a layer of ozone only about as thick as a dime. But why does this matter? Why do we need to know the thickness of this hypothetical ozone layer? Well, the concentration of ozone in our atmosphere is crucial for life on Earth. It absorbs most of the sun's harmful ultraviolet radiation, protecting us and the environment. Any significant changes in ozone concentration could have profound impacts on our planet's climate and ecosystems. By tracking the number of Dobson Units in different parts of the world and at different times, scientists can monitor changes in ozone concentration, particularly in the stratosphere. This allows them to study patterns of ozone depletion and recovery, and to make predictions about future trends. So the Dobson Unit gives us a way to visualize and quantify the amount of ozone in our atmosphere. But how do we measure Dobson Units? Measuring ozone in Dobson Units is not as complex as it may seem. So, let's dive in and understand how it's done. Scientists worldwide employ a variety of tools and techniques to measure ozone concentration in our atmosphere. One of the most common instruments they use is the Dobson spectrophotometer. This ground-based device measures the intensity of sunlight and other types of radiation wavelengths reaching the Earth's surface. Here's how it works. As sunlight passes through the ozone layer, certain wavelengths of the sun's light are absorbed by the ozone. The Dobson spectrophotometer measures the intensity of these absorbed and non-absorbed wavelengths, and by comparing these values, the amount of ozone in the atmosphere can be estimated. But scientists don't stop there. They also use satellites orbiting Earth to measure ozone levels. These satellites carry instruments that can detect the subtle changes in radiation as it passes through the ozone layer. By monitoring these changes from space, scientists can gain a global perspective on ozone concentration, which is key to understanding the health of our ozone layer. So you see, measuring ozone in Dobson Units is a bit like taking the Earth's atmospheric temperature. It's a vital part of monitoring the well-being of our planet. Through these measurements, we can keep an eye on the health of our crucial ozone layer. The Dobson Unit plays a crucial role in our understanding of the Earth's atmosphere. These units offer us a glimpse into the invisible, allowing us to track shifts in ozone concentration, particularly in the stratosphere, our planet's protective shield. By monitoring these units, we gain insights into the processes of ozone depletion and recovery. This knowledge is essential in our ongoing battle against climate change and environmental degradation. And that's how we measure the invisible shield that protects us from the sun's harmful rays. Remember, every Dobson Unit counts.